So for today's topic, I will share more on the WAF motion and type of operation. So this is the topic for today. Let's start the sharing. Okay, basically for the WAF motion, it can be categorized into linear or rotary type. For the details, I will discuss about that later. Okay, for the linear WAF. For linear WAF, they normally will use a closure member that move in a straight line to start, stop, or throttle the flow. As you can see in these short video clips over here, this is actually what we call as the closure member. This is a disc. And then when you see in this video, these short video clips, when you want to open the WAF, this closure member will move upwards in a straight line direction. Similarly, when we want to close the WAF, it will move downwards until it touches the bottom and to create a seal to prevent the fluid from flowing through. So this is how the linear WAF operates. For linear WAF, they are normally slower in operation as compared to the rotary type. Why did this happen? Because especially for the large size linear WAF, right, this closure member will normally need to travel quite a far distance from the fully closed to fully open position. So it takes a longer time to travel from closed to open position. However, for linear WAF, they have a higher level of accuracy and stability in the position of closure member. In other words, when the closure member is in a closed position, it can actually create a tighter seal compared to rotary WAF. Next is about the common type of linear WAF. There are three common types of linear WAF. One is gate WAF, as the picture show on the left. Second one is the globe WAF, the picture at the middle. And then another type is diaphragm WAF, the picture at the right. Of course, there are a lot more linear WAF, but these three are the common types of linear WAF in the industry. And in order to operate the linear WAF, there are a few common operators that will be discussed today. One is the hand wheel, one is gearbox, and another one is actuator. For hand wheel, it is normally used for a small size WAF where the torque value required to open or close the WAF is not so big. So we can just use the hand wheel like this to open or close the WAF. But when the WAF size is become bigger, we normally require a device called as a gearbox, which you can see over here, to reduce the torque value required to open or close the WAF. If not, it will be very not feasible to just rotate the WAF using a normal hand wheel, because the torque value required is very huge. And for the hand wheel and gearbox, they are considered as a manual type linear WAF. And for another type is the actuator type. As you can see for the picture over here, we can either use pneumatic, hydraulic, or even electrical type actuator to control the WAF open or close by itself. We don't need the main power to go and rotate it. So this is considered as a control type of operation. Okay, then for the stem design, linear stem design, there are two types. One is the rising stem and another one is the non-rising stem design. For rising stem, the stem will normally move vertically upwards when the WAF is open. As you can see the picture over here, when the WAF is in closed position, this closure member is for this case is a gate. It touches the bottom, and when you want to open it, the stem will slowly move upwards until it become a higher level than the hand wheel, as you can see here. So by looking at this, right, when you look at the rising stem, you know that the WAF is in open position. When you see that the stem is in the almost same level as the hand wheel, you know that the WAF is in closed position. So for this rising stem design, it can actually help the operator to know the WAF is in closed or open position easily. Here is the short video clip showing the actual operation when you open or close. As you can see, when we open, the stem will come out from the hand wheel. When we close, the stem will move downwards and become as the almost same level as the hand wheel. So this is the first type, which is the rising stem. Second one is the non-rising stem design. For non-rising stem design, the stem will remain in the same place, but the closure member will move upwards or downwards when the valve is open or closed. As you can see the picture over here, when the valve is closed, this closure member can be either gate or plug, or this will be in a bottom position. And then when we open the valve, they will move upwards to the thread in the middle. So for this case, it is the closure member move upward instead of the whole stem moving upward. Because you can see that the level of the stem remain the same, but just that the closure member moving up or down. So this is the rising stem design. For rising stem design, it is normally recommended for the clamp packing type. Because for the packing side, normally we use the clamp packing, and let's say if the stem is keep moving up and down, it will normally cause a wear and tear on the clamp packing. For this one, we will discuss that later. Then the next one is a small comparison between a rising stem and non-rising stem valve. For the advantage of rising stem design, we can easily identify the valve is in open or closed position. As I mentioned just now, by looking at the stem level, whether it is the same as the hand wheel or whether it is much higher level than the hand wheel, then we can know whether the valve is in open or closed position. However, for the disadvantage, it requires a large space on the top. Because when we are in an open position, the stem will come out from the hand wheel, so you need to conserve a space on top in order for the valve to be in a full open position. If let's say you have maybe piping or sealing on top of the valve, the stem might not be able to fully open. So this is something to take note when we are using the linear stem design. For rising stem design. For non-rising stem design, it will normally take up a lesser space, because once you install, you don't need to conserve an additional space for the stem to move upwards. It will just remain at the same position. However, the disadvantage of the non-rising stem is you might need to have an open-close indicator for the operator to know whether the valve is in open or closed position. It is not like the rising stem, you just look at the stem level, you know it is open. So this is one of the disadvantages of the non-rising stem design. Next is stem sealing. Okay, in order to prevent the leakage of the processed medium coming out from the valve inside of the valve to the outside, we normally will need a sealing around the stem area to prevent the fluid coming out. This is what we call as a stem sealing. For stem sealing, normally there are two common types of design. One is we use the clamp packing, and another one is using the bellows sealing. Let's look at the first type, clamp packing. For clamp packing, if you can see the picture over here, they actually have a packing surrounded the stem, and then they will be compressed in order to prevent any fluid from coming out from the top. And the material is normally graphite material to create the steel. And as discussed just now, for rising stem design, the stem will remain at the same position, so it can actually reduce the wear and tear on this clamp packing. If let's say we are using the rising stem, it might cause some wear and tear on the clamp packing and reduce the lifetime of the clamp packing. And next is the bellows seal design. So for this bellows seal design, as you can see over here, there's actually a flexible metallic bellow connected at the one end of the valve, which is the bottom part, to the bonnet of the valve. And this can actually create an effective barrier between the fluid and the environment. This can actually create a seal to prevent the fluid from coming out. The bellow will extend when the valve is open, and it will contract when the valve is closed. And in order to prevent the bellow from rotating, normally we'll insert an anti-torsion device to prevent them from rotating, or we call them as twisting of the bellow, in order to extend the lifetime of the bellow. And for the comparison, for clamp packing type, it is a cheaper option to achieve the stem sealing, but it doesn't produce a tight seal such as the bellow seal. Another disadvantage for the clamp packing is if the valve is not used for quite some time, the clamp packing can get very stiffened, and next time when we use it, right, it will have issue on that. And on the other hand, for the bellow seal design, they does not suffer this issue when we do not use the valve for a long time. And also, it normally requires no maintenance for over 10,000 cycles. However, for bellow seal design, the cost is much higher. So it depends on your application. You can choose either design to achieve the stem sealing. Next is back seat features. For linear valve, they have this so-called back seat features, and they will. So if you can see at the picture over here, back seat is actually one of the part that is on top of the closure member. Normally, plug or gate is on top of them, and then when we open the valve, this back seat will move upwards until it touches the bonnet with the back seat ring to create a seal. This is actually a sealing to prevent the fluid from coming out on top also. So why we need these back seat features is actually when we have this back seat function properly, the operator can actually change the clamp packing if there's any issue. And in order to ensure that this back seat is functioned properly, normally there's a requirement in the industry to do the back seat test. And the standard to follow is normally API 598 or maybe some ISO standard. It depends on the application to determine the testing duration, acceptance criteria, and testing pressure value. When the valve has passed the testing, then when you install at the site, it's supposed to have no issue, and you can do the online changing of the clamp packing. If let's say there's some issue on that. And for the advantage of the linear valve, they can actually offer a precise accuracy and tighter shut-off compared to rotary valve. But the disadvantage is the valve is much larger, especially for a large size linear motion valve such as globe or gate. And also we need to cater for the long stem to lift the closure member. Okay, before I proceed, let's see some comment. Okay, I see some new friend coming in. Hello, Ruzaini. Hello, Jiaqian. Hello, Haniza. Hello, Iza. Hello, Naziha. Hello, Woon. Hello, Shawao. Okay, let's continue the section. Okay, for rotary motion valve. Next is about the rotary motion. For rotary motion valve, they will rotate a closure member, either a disc or ball, using a circular stem. This one, circular stem, which extending across the diameter of the opening. And for rotary motion valve, they also known as the quarter turn valve because the valve is in fully open or fully closed position when we rotate from 0 degree to 90 degree. And some of the examples of the quarter turn valve are ball valve, plug valve, and butterfly valve. Here are some of the picture, like for example, this one at the left. You can see the stem is connected to a ball, and when we want to open the valve, we just need to rotate the lever from 0 degree to 90 degree. Then we know we can fully open the valve. Similar to a plug valve at the middle, we just need to rotate the hand wheel 0 degree to 90 degree to fully open, or rotate anti-clockwise 90 degree to close the valve. And for the butterfly valve, similar also, we just need to rotate the 90 degree to open or close. Next is the common operator for a rotary valve. There are three. One is lever, one is gearbox, another one is actuator. For lever type, it is normally for a small size valve. When the torque value required is not very huge, we can just hold the lever, rotate 90 degrees to open, or rotate another 90 degrees to close it. However, when the valve size is getting bigger, we might need a gearbox to reduce the input torque required to operate the valve. Similarly, when we want to control the valve open or close, we can use actuator, which can be either pneumatic, hydraulic, or even electrical type. Next is the stem sealing of a rotary valve. For rotary valve, normally they will use O-ring as the primary seal and packing as the secondary seal. As you can see the picture over here, when the valve, when the process medium is coming from the pipeline, and then they might go through the cavity, and then they might coming out from around the stem area. So we need to have an O-ring as the primary seal to prevent them coming out, and then the packing as the secondary seal to prevent the fluid from coming out to the environment. For the packing, normally it is a graphite material to be used. Here are some of the common types of O-ring material, which you might have heard of it before. The first one is MBR. The temperature range suitable is -25 to 110 degrees Celsius. And for the application, it is suitable for hydraulic oil, vegetable oil, animal fat, acetylene, alcohol, water, and some other application. The second is the HMBR, which it has additional hydrogenated process compared to the MBR, and the temperature range is slightly larger, which is from -30 to 150 degrees Celsius, and it has better oil and temperature resistant than MBR. The third type is EPDM. The temperature range is from -55 to 150 degrees Celsius. The application suitable is solvent, alcohol, ketone, ester, and hydraulic fluid. For EPDM, it is not recommended for animal fats, vegetable, or mineral oils. For the last common type is FKM, or we call them as a white tone. The temperature range is -20 to 200, and it is good for chemical resistant to oil, fats, and fuel. For the last type, FKM or white tone, it is suitable for even vacuum application. Okay, let's see some comment. Okay, I see a question from Jia Chen. How should we choose between linear and rotary valve? Okay, so this one actually depends on your application. Like for example, if let's say you need a quick opening of the valve, then normally we will go for a rotary type. Because rotary type, you just need to rotate 90 degrees, then it can from open to close position. Because especially when the valve size is very big, then you choose the linear type, it might take some time to open or close the valve. Like some of the application, they require a very fast shut off time, then we'll go for the rotary valve. And if let's say you want to go for a tight shut off, then you can choose for the linear type. It is a good option. And then let's say you want to have a control type, like let's say you want to use as a control valve, then linear valve will also be more stable because they can achieve a more accurate control. So it depends on your application. Then you can decide whether you want to go for linear or rotary valve. Okay, I hope I answer your question, Jia Qian. Hello, Miss Jia. Okay, so let's continue the sharing. Oh, by the way, if you have any question, feel free to leave at the comment section, and then I will come back later. Okay, for the advantage. So for a rotary motion valve, it usually will be lesser in weight and is smaller in size compared to a linear valve. Especially when the valve size is very big, a linear valve can be very huge, especially when they need to consider the stem to move to lift the closure member. And also for the rotary type, it's also easier to control the emissions through the stem packing of a rotary valve without the use of barrel seal. So they have a primary and secondary seal instead of using a barrel seal. And they are less prone to the clogging in dirty service application for a rotary valve. For the disadvantage, normally for rotary valve, they cannot offer precise control compared to a linear type due to they have a large opening once the closure member is open. So for a control valve, normally we will go for a linear type because they can achieve a better controllability. So do you all have any other question? Okay, so basically that's all for my sharing today, and stay tuned for more interesting topic by other speaker on the following weeks. So I think that's all for my sharing. Thank you all.